we have some reminders, okay? So with domain from yesterday, denominators can't be 0. That creates vertical asymptotes. And even roots can't be negative. That creates imaginary numbers. And we talked about how a radicand needs to be bigger than or equal to 0. So some sneaky examples are the following. F of x. Ooh, why is this a sneaky example? It creates a denominator. So if I have a negative exponent, I need to be aware that if I rewrote that, it creates a denominator. So now x can't be 0. That would be part of my domain. Looking at the next one, why is this sneaky? So from the rewrite, hey, wait a second, now I have an even root. This is called an even root because the index is an even number. X can't be negative, so the way we represent that is domain would have to be any real number as long as you're bigger than or equal to 0. That radicand needs to be bigger than or equal to 0. This is the main point of today. Composition of two functions. Notation. This is what we're going to symbolize it as. So the ending result, that's how we're going to interpret h of x. The ending result of a composition will either look like this. So you need to know if I'm taking the ACT or the SAT. You might see this, or you might see this. It almost looks like multiplication, but it's an open circle. Little open circle. And we read it as, okay, h of x equals f of g of x. That's how I read that. F of g of x. Where I'm going to do g's function first and plug that into f. We're going to see what this looks like with numbers. We're going to see what this looks like with numbers if I was plugging in. And what if I was just plugging in an x? So we've got some functions here, and we're going to learn what happens if I start with x, plug it into g's function, and then plug it into f's function. So notice the two differences in this language. I say f of g of x when I read it, but I interpret it as kind of like a foreign language where you work backwards. If you think about it in a foreign language, if I was learning Spanish, I would say camiseta negra for black shirt. Notice how they do their adjectives last and then their noun, so it's like they work backwards with that. Same here. I'm going to start here. This is my input. I'm going to plug it into G. Can we figure out what G's function does? If x minus 2 is G's function, or subtract 2 is G's function, if I start with x, so now this, I'm now at x minus 2. I started with x, I did G's function, which is subtract it by 2. Now I'm going to take that expression and apply f's function. We've got to figure out, well, what does f do? So to recap, because f's function takes its input, raises it to the negative 1, and then multiplies by 2, I'm going to take that x minus 2, raise it to the negative 1, and multiply by 2. Notice how this looks exactly like f's function, but without this input, because the input is going to change. It's no longer f of x, it's f of x minus 2. So I'm going to put x minus 2 in parentheses. 2 over the quantity x minus 2. Since x minus 2 was in parentheses, raised to the negative 1 power, it's going to move to a denominator. Let's also discuss domain. So looking at that denominator, x can't be 2. Now, if we were to leave the function as this, without it being put into a fraction form, we need to be aware of the sneaky negative exponents. That would still affect our domain. So some of us would be, if we did a t-chart and we tried to plug in 2, some of us would be like, I don't know what I'm doing, I'm getting an error. So we need to recognize these sneaky examples that, yes, sometimes we're going to get errors. All right, now let's see how this is going to be affected if I'm given a number. So I'm going to be given a number first. I'm not multiplying. This is not multiplication notation. I'm plugging in. So I'm going to take 2, plug it into G's function. And then that's going to spit out a number that I'm going to plug into F's function. So this 2 that I'm plugging in replaces the x. And now I'm going to plug 0 into f's function. So 2 times, wait a second, a negative 1 power means you're going to have 2 over 0. Undefined, no solution. I shouldn't say no solution, it's not a solution, meaning 2 is not a solution of this composition. So there is a method to this madness. I wanted you to see that if we tried to plug in 2 into this composition, that, yeah, the domain makes sense. If you try to plug in what you're not supposed to plug in, you're going to get errors. Looks similar, but we're doing a different order. That's how we need to interpret this. We don't look at it as multiplication. We look at it as a different order. Now, I'm going to start with x and do f's function, and then plug that into g's function. Instead of f of x, I'm going to have my number, wait a second, my bad, 2 divided by x. So instead of f of x, I'm putting in f's function, 2 over x. You could have also kept it as 2x to the negative 1. Both of those are the same, just written differently. I'm going to keep 2 over x. But now I'm going to take that expression and do g's function. G's function is take your number, take your input, and subtract 2. So I'm going to take this input and subtract 2. So this input is now going to subtract 2. So the composition, g of f of x, equals 2 over x minus 2. So recap, because that's denominator, or because denominators can't be 0, that means my domain should not plug in 0. So, good. Let's plug negative 3 in first. Let's plug negative 3 into f and then into g. So 2 divided by that number. So now I'm plugging in what? Negative 2/3. So if I wanted to clean it up, plugging in negative 2/3 into g's function. Well, what does g's function do? It takes whatever it gets and subtracts 2. So I'm going to take negative 2/3 minus 2. So recap. We plugged negative 3 into f. And then we took that value and plugged it into g's function. Notice how I'm no longer paying attention to this f of x notation or this g of x notation. Those are names. Those are names. So I literally go to the expression on the other side of the equal sign. G's function subtracts 2. So now we're looking at a composition within itself. Like, so when you plug x into f, you take your input to the negative first power and then multiply by 2. If you want to see that as 2 over x, you can. Both of those mean the same thing. But then you're still going to take this input and do it again. Take this to the negative first power and multiply by 2. I'm going to use the first notation so I don't run out of room. But I'm going to take that expression, that 2x to the negative 1, and I'm going to raise it to the negative first power and multiply it by 2. And then we're going to see what happens. So wait a second, let's simplify this. I still have a negative 1 here, so I get 2 times x over this red 2. Or maybe I'll make it a blue 2. So that means the composition of f of x turns out to be just x. So then what about its domain? Here's the bad thing. Along the way, we had fractions. When I say along the way, f itself had a fraction. So we need to be aware of, if I were to try plugging 0 in here at this step, because x is being raised to the negative first power, your calculator would actually say undefined. So we need to avoid 0 because of that right there. So domain is all real numbers except 0. Something I did not stress is in compositions, wait, no, maybe I did. In compositions, if you get a hiccup along the way, if you plug 0 in along the way and you get an undefined or an error situation, it stops the whole function. So you've got to make sure, did I have any denominators along the way? This is the first case that we've had thus far. Well, let's plug in 5. Granted, we're not plugging in 0, we're plugging in 5. Which we could look at as 2/5. 2 over the number. Well, if I wanted to take that input, I'm going to take that input, 2/5, raise it to the negative 1 power again, multiply by 2, and like we had a side conversation about, we flip this fraction, so 2 times 5/2 spits out 5. All right. No domain on the ones where you're plugging in a number. No domain when you're plugging in a number. When you don't know what you're plugging in, that's when you're checking for domain. All right. Well, let's repeat the same process, but do G's function again. So then I want to subtract 2 again. I want to take that input and subtract 2 again. So G of x becomes x minus 4. So plugging 0 into G once, I get negative 2. When you plug negative 2 in again, the output becomes negative 4.